In this video, we are going to see how we can solve exponential equations. Exponential equations means that the variable is at exponent. And this one we call base. B at x, base to the exponent, we call it power. One way we can solve is we change both to the same base. Left side is one power, right side is another power, and they have the same base. And we use the property of exponential functions. If we have the same x and the power equals, y value equals, we have only one x value corresponding one y. So we use this property. If the two power equals, the base same, then the exponent will be same. So based on this property, we could change the both sides to the same base. Then we let the exponent equal. If we have different exponent, we could use a logarithm. So exponent equals log power divided by log base. So if we have an equation base to the exponent equals power, then if we want to solve the exponent, we could just use a log power over log base. Then you will be able to solve exponent. This is grade 12 curriculum, but if you use this to solve the exponential equation, it's okay. So now we are going to see how we are going to use either the same base, then let the exponent equal to solve, or use a logarithm. So 3 to the exponent x equals 27. This side we have the base 3. Then we want to change the 27 to base 3. So we are going to use a factoring tree to find the factors of 27. 27 is not even number, so it won't be able to divide by 2, so we try the 3. 27 divided by 3 is 9. Then 9, we try the 3 again. 9 divided by 3 is 3. So the end of each branch of this factoring tree, they are the factors of 27. So 27 equals 3 times 3 times 3. Then it is 3 to the exponent 3. So we have the same base, the power equals, then we know that you have only one x value give you the same power. So x equals, the exponent should equal x equals 3. We drop the base. If we want to use the exponent, the logarithm, we could write the exponent equals log. This is power 27 divided by 3 is the base. So log power over log base, then you will have the x value. And you could use a calculator to find the log 27 over log. We could use calculator log 27, the log power, divided by log 3, the base, equals, it gives you the 3. So that is the same as x equals 3. So either the same base, or you could use a second method. Use a log power over log base equals exponent to solve x. So this one, same thing. We could 6, 5, 6, 1, we tried 9 to the exponent. You will find out is x. You try the guess and check. Then the same base, the power equals, and the exponent will be equal. So drop the base, x equals 4. Or you could use a second method to use a log to do it. So exponent is x equals log, this is power 6,561 divided by log 9. Then we are going to see log 6,561 divided by log base 9. Then equals, it gives you the 4, so it's same as a same base. Then continue to solve this, and be careful this one you are not able to use a second method to do it right away, because the base, if we do the log, need to be positive. So what you could do is, okay, we are going to -4 to the exponent m equals, we are going to see -4 to the exponent what to give you 4,096. So we are going to do the guess and check. So -4 bracket to the exponent, we may try the 6,496. Yes, so it's -4 to the exponent 6. If the number too big, then you can try a lower exponent. So then same base, the exponent will be equal, m equals 6. But when you use a log, be careful. You need to use a positive base only, because exponential function, we have learned for exponential function, the base need to be positive. So we are going to try the log positive base only, and check after we have the answers. So we use a positive number only, log 4,096 divided by log 4, positive base only, it gives you the 6. So m equals 6, then you check it. M equals 6, and be careful, if the base is negative, you need to check if they are correct. So left side equals -4 to the exponent 6, then you type in equals 4,096 equals right side. Then it means 6. It is a solution for this exponential equation. So the next one, we do the same thing. You could guess and check -5 to the exponent 3 to the exponent x equals -5 to the exponent, guess and check, is 3, so x equals 3. And if we use a log, we just x equals positive base. We use both positive, otherwise it doesn't work. X equals 3, then check. Check the left side equals right side or not. So you will see the left side equals, so check again. Left side equals -5 to the exponent 3 is -125 equals right side. So the solution x equals 3 is correct. So this is each side we have only one number, one factor, or one power. So example 2, you will see some equation you have two factors, the base not same, or the exponent have two terms, or the left side you have adding subtracting two terms. So in order to solve it, we need to make sure one side is one power only. So we are going to move the 3 to other side. So 4 to the exponent x plus 3, so one base at one base, one exponent at one side, so this one is 1024. Then you could guess and check, or you could just use a log. X plus 3 equals log 1024 divided by log base. Then x plus 3 equals, we do the calculation, log 1024 divided by log 4 is give you 5. So x plus 3 equals 5. Then this is a linear equation, so we are going to isolate x, move the numbers to other side by doing opposite operation. Plus 3 becomes minus 3, so x equals 2. And this is done. You could always check it, sub it in and see if 3 times, so this is optional, so you could check by substitute the x equals 2 to the left side. 3 times 4 to the exponent 2 plus 3. Then see if that one equals 3072. So 3 times 4 to the exponent 5 equals 3072. So it is equals the right side. So we know that our solution is correct. Solving equation is looking for the variables, the value for that variable that will make left side equals right side. So this one we have the same base already. We could just drop the base, the exponent equals. So once we drop the base, exponents are equal, then you have a linear equation. So we could move the 7x to the one side, or the x to one side and number to other side. 7x moved to other side is minus 7x. So we have negative 4x equals negative 2. Then we want to isolate x, we move the negative 4 to other side. Opposite operation will be divided negative 4 to both sides. Then negative 4 divided by negative 4 give you 1x. Negative 2 over negative 4, the lowest form, give you 1 over 2. So negative negative becomes positive, and you could check it again by subbing it back. And the last one, we have 1 power plus 2 equals at 1. We want to move the 2 to other side by doing opposite operation. It will be minus 2. Then we are going to have 5 to the exponent x minus 3 equals 78,125. And we could use a log x, exponent x minus 3 equals log power divided by log base. Then x equals, we move the negative 3 to other side, it's positive 3 plus this log. So 78,125. So log 78,125 divided by log 5. It is 7. So 3 plus 7. Then we have x equals 10. You could sub it back and check the left side equals right side or not. So here we have used the same base, power equals and exponent equals, or you could use isolate the power by moving the numbers to other side. Then one side you have 1 power, we can use exponent equals log power over log base to get rid of the exponential equation to a linear equation. So, and we are going to practice more. For this one, we have not same base. We have 3 to the exponent x equals 9 to the exponent x plus 5. And for such question, we are not able to do the log power because we have x plus 5 at the same side with the power. So for such question, we want to change them to same base. We want to change the 3 to factor 3. 3 times 3 equals 9, so it's 3 squared. Then to the exponent x plus 5, so change them to same base. Log power over log base only applied when the power and base you don't have any unknown variables. Then we could use that. Otherwise, we need to make some changes. So this one, we are going to apply power of power. So this one, it will be the exponents times, so 2 times x plus 5. Then each side we have same base, 3. The power equals, so the exponent should be equal. 2 times x plus 5. And this is the linear equation. In order to solve this linear equation, we need to get rid of the bracket in order to collect the like terms. So we don't have the bracket, then we could move the variables to one side. They are the like terms. To do the opposite operation, so we have negative x equals positive 10. Then we need to move the negative to other side, divided negative 1 to both sides. Then we are going to have x equals negative divided by negative is positive, x equals negative 10. Then you could sub it back and check. 3 to the exponent 10, negative 10. So if you want to check, you just left side equals 3 to the exponent negative 10. Then you check the answer and check the right side. 9 to the exponent 9, negative 10 plus 5 equals 3 to the exponent negative 5. 9 to the exponent negative 5. And check if they are equal. So we are going to check. Three to the exponent negative 10, or we just check 3 to the exponent positive 10. Then 9 to the exponent 5. So they are same. So it means they are equal. And the next one, for the next one, you have not same base, but the right side, you have only one power without variable. So you could use a log, or you could think, change it to same base. 1 equals any base to the exponent 0. So we could change 1 to the 8 to the exponent 0. So you will have 8 to the exponent 2x plus 6 equals 8 to the exponent 0. Then 2x plus 6 equals 0. This is a linear equation. We isolate x by move the numbers to other side. And when we are solving linear equation, remember we are going to do the solving is backward of by math, adding, subtracting first. So plus 6, move to other side, opposite is minus 6. Then we do the divide, multiply after. So adding, subtracting first. Then we move the 2 to other side, is opposite operation is divided by 2. So x equals negative 3. Then you could check, sub it back. 2 times negative 3 give you negative 6. Negative 6 plus 6 is 0. 8 to the exponent 0 give you 1. So it's correct. So this one, you could change both to the same base. You could do this one is 1 over 5 to the exponent 3, then write it as negative exponent. Then you will have 5 to the exponent 2x equals 5 to the exponent negative 3. 2x equals negative 3, then divide by 2x equals negative 3 over 2. So this is one way to do it, or we could do the, for both, we could do the, because the right side is 1 power, no variables, we could do exponent equals log power divided by log base. So use a calculator. Log bracket 1 divided by 125, then bracket divided by log 5 bracket equals is negative 3. So you will have 2x equals negative 3, then continue. Move the 2 to other side. You have x equals negative 3 over 2. So it's same as you change them to same base. Then next one is not 1 power. You need to do a little bit simplification. So 3 to the exponent x plus 2 times 3 to the exponent 2x. We want one single power. So same base times, we are going to add the exponent. Multiplication law. So same base, we can add the exponent if they times. Then 3 to the exponent, collect the like terms, 3x plus 2 equals 6561. You could check what 6561 equals 3 to the exponent, or you could just do the exponent equals log power 6561 divided by log base. Then we have 3x plus 2 equals log 6561 6561 divided by log 3 equals 8. Then this is a linear equation again. We move the plus 2 to other side. Do the opposite operation is minus 2. So 3x equals 6. Then move the 3 to other side. By doing opposite operation is division. 3 times x. Opposite of multiplication is division. So x equals 2. You could sum back, check left side equals right side or not. And next one is a little bit challenging because they don't have the same base. So first thing, we need to combine them to one single power. We need to change them to the same base. And we are going to try to change the base to smaller number. So 4 and 16, we could change them to 4. So 4 to the exponent x plus 2 divided 16, we could get it is 4 times 4 is 4 squared equals 1024. The power with same base division we are going to do is subtract the exponent. So this is power of power is 2 times x multiplication. Then after that, we do the subtraction for division. Equals 1024. Then 4 to the exponent, collect the like terms. Same variable, same degree, they are the like terms. We just add, subtract the number at front of the like terms. No number means 1. 1 minus 2 is minus 1x plus 2. Equals 1024. Then exponent equals log power over log base. negative x plus 2 equals log 1024 divided by log 4. Equals 5. Then we could move the 2 to other side. It's minus 2, so negative x equals negative 3. Equals positive 3, then move the negative 1 to other side, doing the division. X equals negative 3. Then this is done. So in this lesson we have show you two methods. One is one side change it to single power, then we could change both sides to the same base. Then let the exponent equals and solve for the unknown. Or we could use a logarithmic. The exponent equals log power over log base and solve. Thanks for watching.